With the name of God, I begin my class. Hello, my dear class. How are you all? Class, today I am with assignment number 2 discussion class. And this video is just going to help you in finding or selecting the correct answers and to prepare you for your final exams. So, we begin the discussion with MCQs. The first MCQ is aqueous potassium iodide, Ki is the formula, can be used as a test reagent in redox reactions. Iodide ions are readily dash a positive result for the test in which the solution changes color from dash to dash. Which words correctly complete gaps X, Y, and Z? So this statement is telling you that you are doing some redox reaction. And you know what redox reactions are? Redox reactions are those chemical reactions in which gain or loss of hydrogen, oxygen, or electron takes place, and this redox comes from reduction and oxidation. So whenever we study redox reactions, they accompany by transfer of electrons. Now we see what is given. Potassium iodide is the chemical reagent which is used to detect the change, and iodide ions are readily dash. So first we see what type of ions are present in our reagent. Potassium iodide is the formula Ki, and this is the state in which potassium is present in its positive 1 oxidation state, and iodine is present in iodide, means it is present in its -1 oxidation state. So we see whenever it will be reacting, there must be some change on this iodine. Iodide is present in -1 form, so it cannot undergo further -1. It must be changing to iodine, in which the oxidation state is 0. So when the charge changes from negative to 0, means it is the loss of electron, and the loss of electron is called as oxidation. So option C and D seems to be wrong. So we go further. What's ahead? It says iodide ions are readily X. So we are thinking about A's and B's. They must be oxidized. And the positive result for the test in which the solution changes colors from Y to Z. You know, whenever iodine is present in its ionic form with -1 charge on it, it is colorless. But when molecular iodine is released in the medium, in the conical flask, it is brown in color. So you have to memorize these things and you have to select the right answer. We go ahead. The question is, which element is most likely to be used as an industrial catalyst? Look class, whenever we talk about catalyst, industrial catalyst means some large amount of reaction is going on with bulk of quantities, and catalysts are used in industries to get good production, to get high number of products, or to get good yields. And the speciality of transition metals is always make them available in the industry, and they are utilized as a catalyst. So you see, among the 4 options, which is a transition element or transition metal, sodium is a very reactive metal. It readily reacts with air and water, with moisture. So a catalyst must be chosen on the basis of its stability, not on the basis of its reactivity. So A is omitted. What about strontium? Again, strontium is in group 2A, a reactive metal. It can't be used as a catalyst. What about C? C is lead. So when we see option B, it's nickel. Yes, I tell you here, these are nickel, platinum, and palladium. These three transition metals are used as a catalyst. Now the next MCQ is, which solution contains 1 mole per dm cube of the compound would have the lowest pH? Okay, it's the question from the acid and base chapter. We see the pH range is from 1 to 14, and we see in between the pH 7 shows the neutrality of any substance. The lowest pH means the strongest acid must be plotted here. So you see among the 4 options which substance is strongest acidic in nature. You select your answer. The next is, which statement about oxide is correct? Yes, this MCQ is from chapter acids and bases, and we see oxides are those compounds in which oxygen is bonded to some other element, which can be metallic, which can be non-metallic. So you see there are 4 options. The question is asking about the selection of the correct statement. So we start with A. A basic oxide is an oxide of non-metal. No, it's wrong. All known metals form acidic oxides such as carbon dioxide, such as sulfur trioxide. And option B, acidic oxides contain ionic bonds. No, it is not the condition. All the acidic oxides are covalently bonded. C. An amphoteric oxide contains a metal. Yes, it seems much sensible. We will think about it later on. Now, when we see option D, basic oxides are always gases. No, it is wrong, because basic oxides are solids at room temperature and they are not gases even. For example, calcium oxide. So when we read option C again, an amphoteric oxide contains a metal. Yes, amphoteric oxides means oxide of aluminum or lead oxides. These are the oxides containing metals aluminum and lead in them, and they show dual properties of acidic oxides and basic oxides. The next is bitumen, diesel, naphtha and paraffin, kerosene oil are all fractions obtained by fractional distillation. Fractional distillation of petroleum. Petroleum is the raw mineral to get so many valuable organic compounds, and it is mined from the ground. Now you see which row gives a correct use of the named fraction. To command this topic, which is taken from chapter number 21, you see there is a table on page number 418 to tell you about the names of the fractions or products and their boiling ranges and number of carbon atoms and their uses. When you read it, when you learn it, you will know that which is the correct answer. Bitumen, you know what is bitumen? Bitumen is also called as asphalt or residue, and it is used for paving road surfaces, for roofing. not directly used as a polish. Option B, diesel. Diesel oil is used as a fuel for diesel engines in buses, lorries and trains for heavy automobiles. When we see for naphtha, yes, naphtha is the lighter fraction, and it is used as a feedstock, means the raw material for the petrochemical industries for the making of other compounds. And for option D, paraffin. The paraffin is also called as kerosene, and it is used for aircraft engines, and it is used as a fuel in oil stoves and heatings. So you select the right answer after learning this table. Sorry, this is the wrong writing. Okay, when we go ahead, number 6th MCQ. An element is in period 3 and of group 7 of the periodic table. Which statement about this element is correct? You know, the period number, the group number informs us about so many things about the element. When we see the position in the periodic table, the period number tells us how many shells of electrons are present in the element. If the period number is 3, means there must be 3 shells in the structure. And when we see the group number tells us how many electrons are present in the outermost or valence shell. So its group number 7 means there must be 7 electrons in its valence shell or third shell. So we see which is the correct answer. Part A, the element will form +1 ions. No, if element has 7 electrons in its outermost shell, it will be taking just one more electron to complete its octet to get it stable. So when it gains one more electron, the charge will be -1, not the positive one. B, the element will have 3 electrons in its outermost shell. No, if it was placed in group 3, then we can think of this option. The option D, element will have 7 shells of electrons. No, because the period number 3, there can't be 7 shells. There are only 3 shells. Again, we are left with the correct answer, that is the element will have 7 electrons in its outermost shell. Okay, now we come to discuss MCQ number 7, which is a bit tricky, but I know that you are very smart in this task. So we see there's a table which is informing us about the physical properties of 3 elements: copper, chlorine and iron, and the melting and boiling points are there. These melting and boiling point will help us in judging that in which physical state this element is found. Chlorine is a non-metallic gas, light green color gas, which is a gas at room temperature. So its melting point is -101. If it is found in a gaseous state, its boiling point must be lower than 0. So option D is omitted. It must be somewhere -0. It must be below 0 at the minus sign. So we can think of W as -34. Now we see copper. Copper is a solid, a shiny golden yellow color metal, which is a very good conductor of electricity, and its boiling point is given, that is 2582. So its melting point must be lower than 2582. When we see options C and D, they both are omitted. It can't be. It must be lower than 2582. Now the last element is iron. Iron is again a dull grayish shiny metal, a very good conductor of heat and electricity, and it's very high dense also. So we see the melting point of iron is 1539. So its boiling point must be more than 1539. So what do you think about option A? It's also omitted. So we are left with the correct answer. Now we see in this MCQ, the petroleum is separated into fractions by fractional distillation, and which fraction distills off at the highest temperature. You know, when we study the structure of the fractionating tower, we get to know that we are getting different group of compounds at different heights of this tower, and the lightest compounds are rose up in the tower and are collected here in the top of the tower, and the fractions which are collected in the lower ends of the tower means at the bottom of the tower they must be very high, they must be having very high boiling points, and they must be heavy compounds such as liquids or almost waxy solids. So among these options, what do you think for lubricating oils? You know, lubricating oils are having boiling point ranges between 300 and 350 degrees Celsius, and the carbon content it has is between 20 to 35 carbons per molecules. So you select the right answer. Next is ammonia is made by a reversible reaction between nitrogen and hydrogen. You see, nitrogen and hydrogen both are gases, non-metallic gases, and these gases are used in 1:3 ratio to produce ammonia industrially, and this process is called as Haber's process. This is a reversible reaction, and in this reversible reaction we see nitrogen and hydrogen are at the left side and ammonia is at the right side as the main product. Now this enthalpy of the reaction informs us about the thermochemistry of this equilibrium system. Positive sign shows that the system is endothermic, but the negative sign shows that energy is evolved, heat is evolved, means it is exothermic in its nature. Now the question is, what is the effect of increasing the pressure in this process? You know, the pressure is the measure of the volume of gases also, and we have to see if we apply pressure on both sides, then what will be its effect. So we see the gases are those physical states in which molecules move randomly here and there irrespective of their positions, and they want to spread as much as space they are kept in. So when we apply pressure, which side of this system has more number of particles of gases? Reactant side, which is nitrogen and hydrogen, 1 plus 3 giving 4 moles at the left side. When we see at the ammonia side there are only 2 moles. So when we increase the pressure, the equilibrium will be shifted to that direction where less particles are present. Here you see 4 moles of gases are present, and here you see only 2 moles of ammonia are present. By applying pressure, the equilibrium will move towards right side where less number of particles are present. So we will be seeing more ammonia will be produced. Now theory section again is a discussion of a reversible system. Ozone is in equilibrium with molecular oxygen, and enthalpy is plus 143, means the system is endothermic. Yeah, the reaction reaches the equilibrium if carried out in a closed system, because the gases are always handled in isolated system or closed systems. The reaction is started at temperature of 400 degrees Celsius. Okay, describe and explain what happens to the position of equilibrium if pressure is increased. Again, you have to see how many number of moles are present at either side of this equilibrium. The reaction is started at 25 atmospheric pressure, means the pressure applied on these sides, both sides, is 25 atmospheric pressure. So what do you understand by this unit atmospheric pressure? Atmospheric pressure is the unit of pressure of a gas which is on all of us. So it is measured as 1 atm. It's a unit. Describe and explain what happens to the position of equilibrium if temperature is decreased. Okay, the effect is temperature is decreased. For an endothermic reaction, if temperature is decreased, do you think the reaction will be proceeding to give us the more production? No, not obviously, because the temperature is the only driving force which is converting reactant into the product. Describe and explain what will happen to the rate of the reaction if temperature is decreased. Okay, this is repeated, sorry. The next is how the volumes of gases are measured. Calculate the number of moles of hydrogen in 25 cubic meter. Okay, the volumes of gases are measured in decimeter cubes, meter cubes and centimeter cubes. And you are asked also to calculate the number of moles of hydrogen gas in 25 cubic meter. For this, you have to go to chapter number 9, where the topic of mole is explained, and there we will be learning to calculate the number of moles of gases by means of their volumes. Yes, this is called as molar volume. And 1 mole of every gas occupies a standard volume that is 24 decimeter cube. But in this question, cubic meter is asked, and to convert decimeter cube into meter cube, you have to multiply with 0.001 figure. Here cubic meter is given, means you need to convert this cubic meter into decimeter cube first, then you will be finding what is the number of moles in the given volume of the gas. Class, you just practice this. I am here to help you again. You can ask me anytime any kind of question from this topic. I will appreciate your inquiries. Thank you, class. Solve it. God bless you and take care.